At the top of page 175, I just plug those into the calculator. 8 choose 2 is 28, 12 choose 8 is 495. This 8, there should not be a division sign right there, but 8 over 2 in these parentheses is the same thing as 8 choose 2, if you see it written like that. So now what we want to do is we actually want to expand binomials. And the best approach to take is to think, how many pieces am I going to have? Let's put the combinations for each of those pieces, and then we're going to take the first part and the second part, and we're going to deal with them one at a time. So, this first one, x plus 2 raised to the fourth. I could write x plus 2, x plus 2, x plus 2, x plus 2, FOIL out a bunch of times. But we can use the pattern of Pascal's triangle in order to quickly solve this. The first thing we know is that when we've got something raised to the fourth, that means there's actually going to be 5 terms. So 1, 2, 3, 4, 5. The next thing we know is that we are going to have a combination. And each of the coefficients in front from Pascal's triangle come from a combination of the fourth row. Since we've got the exponent of 4, we're going to be coming from the fourth row. So we're going to do 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. That is the pattern of all the coefficients that come from Pascal's triangle. And yes, it is going to be the 1, 6, 4, 1 when we simplify it out. But that is the combination piece in case I had to give you something that's not on Pascal's triangle. How would you find that constant without creating all of Pascal's triangle? And the answer is use the combination pattern. The next piece we know is that the first portion of our expansion is going to decrease by 1 each time for the exponent. So here, this is going to be x to the fourth. The next term is going to be x cubed. The next one will be x squared. Next one will be x to the first. And then finally, x to the 0. And notice how I put those in parentheses just in case we've got quantities that are being raised to the power. And then finally, we're going to take our back term and we're going to increase from 0 up. So 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and 2 to the fourth. So now we can simplify all these individual pieces down. 4 choose 0 is 1 times x to the fourth, and 2 to the 0 is 1. 4 choose 1 is 4, x cubed times 2. Plus 4 choose 2 is 6, x squared times 4. All these pieces are being multiplied. 4 choose 3 is 4, and 2 cubed is 8. And then finally, 4 choose 4 is 1, x to the 0 is 1, and then 2 raised to the fourth is going to be 16. So the final piece then is I can simplify each of the terms. This guy here becomes x to the fourth when we simplify. Here, 4 times 2 is 8, x cubed, we got that group. Here then, 6 times 4 is 24, x squared. 32 to the x, and then finally 16. So there's my full expansion. The next one I want to look at, 2x plus 3 raised to the fifth. Since I've got 5, or raised to the fifth, I'm going to have 6 terms. So 1, 2, 3, 4, 5, 6. And I'm going to use row 5 of Pascal's triangle. So my combination is 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. The next piece is I take my first part of the binomial and I'm going to decrease by 1 power each time. So 2x raised to the fifth, 2x raised to the fourth, 2x cubed, 2x squared, 2x to the first, and then 2x to the 0. And then the final piece is I'm going to take my back term, I'm going to go from the 0 power up. So 3 raised to the 0, 3 raised to the first, 3 squared, 3 cubed, 3 to the fourth, and 3 to the fifth. 5 choose 0 is 1, and then 2x to the fifth ends up being 32x to the fifth times 1. So that's my first term. 5 choose 1 is 5. 2x to the fourth is going to be 16x to the fourth times 3. The next piece, 5 choose 2 is 10 times 8x cubed times 9 when we multiply out each of those individual pieces. The next piece, 5 choose 3, that is also going to be 10. 2x squared is 4x squared, and then 3 cubed is 9. All those individual pieces being multiplied. Actually, 3 cubed, I should say, is 27. Can't make that mistake. 5 choose 4. Well, that's going to be 5, and then 2x raised to the first is 2x, and then 3 to the fourth is going to be 81. And then finally, 5 choose 5 is 1. 2x raised to the 0 is 1, and then 3 to the fifth is 243. So there's my individual terms that I've got right there. And I can combine everything within those terms, which is going to give me 32x to the fifth. Next one, multiply 5 times 16 times 3, that's 240. X to the fourth. 10 times 8 times 9, that's 720 x cubed. 10 times 4 times 27 is 1080. 5 times 2 times 81, that's an easy 810. And then 1 times 1 times 243 is just straight up 243. The final example of expansion deals with a negative sign. And you notice I put plus signs between all my terms. And I do that whether it's plus or minus, so then I don't have to think about negative signs. It is a pattern of plus, minus, but if I plug the minus sign into my actual problem, then when I cube it or I raise to the fourth power, you know when you raise it to an even number, it becomes positive. If I raise to an odd power, it stays negative. The negatives and positives take care of themselves then. So right here, since I'm raised to the fourth power, I'm going to have 5 blanks. 1, 2, 3, 4, 5. And I'm on the fourth row of Pascal's triangle, so 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. I'll take my 3x, and that's going to decrease by 1 power each time, so 3x to the fourth, 3x cubed, 3x squared, 3x to the first, and then 3x to the 0. And then finally my y's are going to be increasing by 1 each time. So here I'm going to actually take the negative y, raise it to the 0, negative y, raise it to the first, negative y, square it, negative y, cube it, negative y, raise it to the fourth. And that's where I see all the negatives taking care of themselves, because for example right here, negative y raised to the fourth will be a positive y to the fourth when it's all said and done. So if I simplify all these individual parts here, 4 choose 0 is 1, 3x to the fourth is 81x to the fourth, and then negative y to the 0 is 1. The second one, 4 choose 1 is 4, 3x cubed is 27x cubed, negative y to the first is going to be times the negative y. So this whole term will become negative when I multiply it in a moment. 4 choose 2 is going to be 6. 3x squared is going to be 9x squared. Negative y squared is going to be just y squared. 4 choose 3 is going to be a 4 times 3x to the first is just 3x, and then negative y cubed is going to be times a negative y cubed. So this whole quantity will be negative in the end. And then finally, 4 choose 4 is 1. 3x raised to the 0 is 1, and then negative y to the fourth is just going to be y to the fourth. So there's my first term, second term, third term, fourth term, and fifth term. So when I simplify, 81x to the fourth is my first term. The second one, I have this negative y here. So 4 times 27 is negative 108 x cubed y. Need that y there. Next piece, 54 x squared y squared. This here, 4 times 3x is 12x times a negative y cubed is a negative 12 xy cubed. And then finally at the end, I get a positive y to the fourth. So once again, this is my first term, second term, third term, fourth term, and fifth term.